We're going into 30, 60, 90 triangles, the last type of special right triangles. Let me flip my laptop around here so I can write. Okay, so 30, 60, 90. So let's look at this blue figure right here. Let's make it nice and big and look off to the side. All right, in a 30, 60, 90 triangle, similar to a 45, 45, 90, across from the angle represents its side length. So if 30 degrees is the smallest angle out of 30, 60, and 90, X is the smallest side. I call him smalls. Out of 30, 60, and 90, 60 is the medium length, medium degree. So that means across from that 60 degrees means that this side I call biggie. Biggie and smalls. And then across from the 90 degrees is the hypotenuse, the height man. So we have biggie, smalls, and hype. Smalls is super important in a 30, 60, 90 because the small side we always want to go to. So if they give us the length of the hypotenuse, we want to go to smalls first. If they give us the length of biggie, we want to go to smalls before we go and find the length of the hypotenuse. Smalls is like the home base. We always want to check in with home base before we go anywhere else. That's what I wrote in green down here. Go to the small guy. Go to smalls. No matter what, we go to him. I call him smalls, short leg, shorty, whatever you want to call him. That's where we always go to. So, for example, in example 1, it says find the values of x and y. So across from 30 is our smalls. Since they gave us that length first of that segment, I can pick if I want to go to biggie or if I want to find the hypotenuse first. We're going to end up finding both of them, but it depends on what we want to go to first. So smalls is always going to be a value. If we go to biggie, I want you to look up here. Whatever this number is, smalls. For biggie, we take smalls length and we multiply it by radical 3. Or in other words, we tack on a radical 3. If we go to the hypotenuse from smalls, we multiply smalls by 2. That's the pattern. That's the pattern that will always be. It's never, ever, ever changing. Never, ever. So if I go to biggie from smalls, I just have to use, let me zoom out so you can see it again. I just have to use this pattern here. And the pattern says I'm taking smalls length and tacking on a radical 3. So smalls is 4. I'm tacking on a radical 3. Now I'm going to go to the hypotenuse. Hypotenuse rule is taking smalls and multiplying it by 2. So I do 2 times 4, which is 8. So those are my 2 answers. 4 radical 3 for biggie and 8 for smalls. Just like 45, 45, 90, there's rules, there's patterns. Same thing for 30, 60, 90. So across from 30 is shorty, and shorty we always want to go to. So in example 2, I'm not giving shorty's length because first I want to identify where shorty or smalls is. So here's 30 degrees across from it. This must be smalls. This must be biggie. And this is hypotenuse. So I wasn't given smalls. I wasn't given biggie. I was given the hypotenuse. So I have to go to smalls first. He's our home base. So from the hypotenuse to the small side. Since prior in the previous problem, I multiplied by 2 right here to get my hypotenuse length. If I'm doing the opposite, I'm going to do what operation? Divide by 2. So x is going to be 4 divided by 2, which is 2. So the small length is 2. Now that I'm back at the home base, and I'm so happy I'm here, I'm going to put a little star. Now I'm going to go to biggie. And biggie, I multiplied by that radical 3. I took whatever smalls was, and I multiply it by radical 3. So I found my two lengths. If you memorize what each length should be, then you're perfectly fine. So remember, across from 30 is smalls. It's always x. That means big E on the other side of the 90 degrees is always smalls times radical 3, and the hypotenuse is always 2 times smalls, whatever small is. We're going to call it x. All right, let's dive into another example. So in this example, I'm given big E. I'm just going to move this guy down with me. So we have him again. So in this example, I'm given my big length, and I know because 30 degrees is written and across from 30 degrees is smalls, and he is not given. There is no length there yet. So I need to find smalls. So if I'm at big E and I'm going to my small side, since going to him, I multiplied by radical 3. Now I'm going to divide by radical 3. So very similar steps as we did with the 45, 45, 90. I'm going to take my side length, 10 radical 3, and I'm going to divide it by radical 3. But I cannot have the wizards of math say, heck no, you cannot have a radical 3 in the denominator, so I need to multiply it by itself in order to get rid of it. And when I do the bottom, I got to do the top. If I multiply straight across, I get radical 3 times radical 3, which is radical 9, and square root of 9 is a perfect square. It becomes 3. The same thing happens in my numerator. Radical 3 times radical 3 is square root 9, or radical 9, which is 3. And this 10 gets plopped on over, going through the motions. So now I have 10 times 3 divided by 3. Well, 10 times 3 is 30. Divided by 3 is 10. So in reality, I just did all this algebra just to take this big number and put it down here. So if your big side has a radical 3 already in it, and that's the side you're given, and you have to go to the small side, do yourself a favor and avoid all of this math. Just take the number in front of the radical. We're doing all this just to eliminate the radical 3. So the small side is 10. Now to find the hypotenuse, from smalls to hypotenuse, what operation do I have to do? Multiply by 2. So my hypotenuse is going to be 2 times 10, which is 20. So my smalls is 10, my hypotenuse is 20. The biggie they gave us, 10 radical 3. All right, there's a couple examples where it says you try. We're going to do them together. So in example number 1, did they give you biggie, smalls, or hypotenuse? They gave us smalls. It's across from 30. So to go to my big side, what do I have to do? Multiply by radical 3. So my answer is 12 radical 3. Can't simplify, can't do anything else. Now I'm going to go to my hypotenuse. What's my operation to get to my hypotenuse? Multiply by 2. 2 times 12, I get 24. I don't like the way that looks. It was a bit sloppy. All right, example number 2. Did they give me biggie, smalls, or hypotenuse? They gave me my hypotenuse. It's 6. So I always want to go back to which side? Smalls. I always want to go back to smalls. He's my home base. What operation do I do to get back to smalls? I divide by 2 because I multiplied by 2 to get to 6. So I'm going to get to y. I have to divide by 2, which is 3. So smalls is equal to 3. Now I want to go to Biggie. What is my answer for Biggie? I want to multiply by radical 3, so I have 3 radical 3. All right, did they give me smalls, biggies, or hypotenuse? They gave me the big side because across from 30 is my smalls. So this means this must be biggie. And that's hypotenuse. Which side do I want to go to from the big side? Smalls. Always want to go to him. He's our home base. What operation do I need to do in order to get back to smalls? I have to divide by radical 3. So again, 15 radical 3 is my big side. Remember our shortcut. If there's a radical 3 here, we just take the number in front. That's going to be our small length. But if you don't believe me and you go through all the work of dividing by radical 3, the math wizards say heck no to radicals in the bottom, so you multiply it by itself. This becomes square root 9. This becomes square root 9. Both of those simplify to 3. The 15 gets brought over, so now you have 15 times 3 divided by 3. Well, 15 times 3 is 45, and 45 divided by 3 is 15. So you just did all that work to prove that you were just taking the number in front of the radical 3 for your small side. All right, and now what's the length going to be for the the hypotenuse? It's going to be 2 times 15. So 30. All right, so our total operations were either multiplied by radical 3, or we're going to multiply by 2. So if we're given smalls, they give us the small length. We're going to multiply by radical 3 or multiply by 2 to fill in the other sides. If they give us biggie, we have to work our way back to smalls. So we have to divide by radical 3. If they give us the hypotenuse, we have to work back to smalls. So we have to divide by 2. Those are the only operations we've been doing, either multiplying by radical 3, multiplying by 2, or the opposite, dividing by radical 3, dividing by 2. Just to sum up what we've been doing in those questions. All right, we'll save these trickier ones for a different day.